What I hear, I forget. What I see, I remember. What I do, I understand. Zuni. So in section 2.3, we're going to be looking at some ways of finding the zeros. And so the first algorithm is a division algorithm. So if f of x and dx are polynomials, such that dx is not equal to 0 and the degree of dx is less than or equal to the degree of f of x, then there exists a unique polynomial qx and rx such that f of x is equal to dx times q of x plus rx. D of x is the divisor, q of x is the quotient, and rx is the remainder. When rx is equal to 0, the degree of rx is less than the degree of dx. If the remainder rx is 0, then dx divides evenly into f of x. So when we want to apply this theorem or algorithm, we need to write the terms of the dividend and divisor in descending powers, insert placeholders with 0 coefficients for missing terms, and we'll discuss this as we go through the examples. So if we want to divide the polynomial 5x squared plus 3x minus 2 by x plus 1 using long division, then we can write this as x plus 1. And then we have 5x squared plus 3x minus 2. So the x plus 1 is what we call a divisor, and whatever's inside of the box here is a dividend. And so when we're dividing, let's say, a number, something like this, then we ask ourselves how many times does 2 go into 17? That's 8. So then we multiply 8 times 2 is 16. And then we subtract 17 minus 16 is 1. And then we bring down the next number and we start the process again. 2 goes into 11 5 times. And now since 2 is greater than 1, we can stop. This is your remainder. This is your quotient. This is your divisor. And this number is your dividend. And so when dividing polynomials, we have the same process. And so here we have 5x squared. We need to make sure that they're in descending order. So we have a 2 and a 1, which is in descending order. And so here 5x squared divided by x is going to be 5x. In other words, 5x times x is 5x squared. And 5x times 1 is 5x. Then we want to subtract, but we're going to be subtracting everything in this parentheses. So by doing that, we're distributing this negative into both terms. So now we would have 5x squared minus 5x squared is 0. And 3x minus 5x will give me a negative 2x. Our next step is to bring down this negative 2. And so we start the process again. So x goes into 2x. My negative 2 times. So negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. Since we're subtracting, like we did here, basically by subtracting this entire thing, we're changing the sign of each of these terms. So instead of a negative, this will become positive because negative and negative is positive. And then negative and negative will also be positive. So negative 2x and 2x is 0. Negative 2 and 2 is 0. So we say that our remainder is 0. This is our divisor, x plus 1. And then our quotient is 5x minus 2. And everything in here is our dividend. So to write our answer, we write it as our quotient plus the remainder divided by our divisor. Okay, so my quotient here is 5x minus 2 plus my remainder of 0 divided by the quotient. Whenever we get remainder of 0, this is going to be very helpful, and we can say that if the remainder is 0, then the divisor is a factor of the polynomial. And basically what this means is you have a factor. So your quotient, your divisor is a factor, so x plus 1 is a factor. And once we know the factor, then we can find the 0 by setting that factor equal to 0. So since your factor was a 0 and we got remainder of 0, we can also use the quotient will also be a factor. So we get that x is equal to 2/5 is your other 0. Okay, so your factor and quotient would be zeros, which again is what we were looking for in the last section. Here's -1 and then 2/5. So again, we can do this only if the remainder is 0. So let's try another one. We have 3, and we're going to divide x cubed. Make sure they're in descending order. So we have 3, 2, minus 5x plus 5. So the powers are in descending order. And then I have x cubed. How many times does x go into x? So that's x squared. X squared times x is x cubed. X squared times -3 is -3x squared. Since we're subtracting, we're changing the signs for each of these. So x cubed and negative x cubed cancel. 4x squared plus 3x squared is 7x squared. Bring down the next term. So minus 5x. And then we ask ourselves how many times is x going to 7x squared? So that's going to be 7x. 7x times x is 7x squared. 7x times 3 is -21x. Change the signs. So that cancels. 5x plus 21 is 16x. Bring down the 5. How many times does x go into 16x? That's going to be 16. 16 times x is 16x minus 48. Change the sign. So this cancels, and then we get 53. So our answer is our quotient, which is x squared plus 7x plus 16 plus the remainder of 53 divided by our divisor. Since we didn't get the remainder to be 0, then we cannot find the actual zeros. Go to the next page. And let's divide one more. So first, we need to write these in descending order. So my divisor here is 3x plus 1. And then we have a 6x to the 4th minus x cubed plus 9x, or actually x squared here, minus x squared plus 9x minus 3. Okay, so I'm going to start the problem and then we'll go from there. So 6x to the 4th, 3x goes into 6x to the 4th. That would be 2. 2 times 3 is 6. And then we have x cubed. So 2 times 3 is 6, x to the 4th plus 2x cubed. Change the signs. So this cancels, and then negative 2x cubed minus x cubed is negative 3x cubed. Bring down the negative x squared. So 3x goes into 3x cubed. That's going to be x squared. So 3x times negative x squared is negative 3x cubed. And 1 times x squared is negative x squared. Change the signs. So we cancel here, and this will become 0. And so we bring down the 9x. Okay. And so for 1 point on quiz 4, go ahead and finish the problem. Show your work. You can email it through an attachment. If you do this correctly, then your answer at the end will be 2x cubed minus x squared plus 3 plus negative 6 divided by 3x plus 1. Okay. So the next way to divide polynomials is called synthetic division. And to use synthetic division, the divisor must be in this form, x minus k. So again, we do put our coefficients in descending order. And so this a is going to be the coefficient in front of x cubed, b is in front of x squared, c is in front of x, and then d is your constant. And then we're going to be using k to write it on the outside. So then we bring down the first number, and then we're going to multiply k times a, gives us ka. And then in here, we're going to be adding ka plus b. And then we start the process again. K times all of this will go up here, and then we add, and then that goes down there. Yeah, so for example, first make sure that your divisor is in the form that we need. So notice we have an x, and then we have a plus, but we should have a negative. So this x plus 2, we can rewrite it as x minus negative 2. And so now it does look like the form that it should be. So that means that your k is negative 2. So we're going to have a negative 2 on the outside. And then the coefficients, we have a 3x cubed. So I'm going to use the coefficient of 3. Notice I don't have an x squared, so I need to use a 0 for that as a placeholder. And then we have 6 and 8. Okay, so this comes from 3x cubed plus 0x squared plus 6x plus 8. So we're using the coefficients to write them in here. So our first step is bring down the 3. And then we're going to multiply negative 2 times 3 is negative 6. Okay, so we multiply this. And then we put our answer in here. And then we add. So 0 plus negative 6 is negative 6. And we start the same process. Negative 2 times negative 6 is positive 12. Plus 6 will give me 18. Negative 2 times 18 is negative 16. Negative 36. Plus 8 will give me a negative 28. The last number is what we call the remainder. And the numbers before that will make up our quotient with 1 less power from the original polynomial. Okay, so our original polynomial had degree 3. So when we write our quotient, we're going to use the 3 as our coefficient, 3x, and then 1 less power of 3 would be 2 minus 6x plus 18. And so this is going to be our quotient. So our answer, we will write as our quotient 3x squared minus 6x plus 18 plus our remainder, which is negative 28, divided by our divisor, which was x plus 2. Okay. So the number that we use here, if you can think of it as you have x plus 2, so I use the opposite of what's here. So if it's a plus 2, then I use a negative 2. If you see a minus a number, then you use the positive. Let's try another example. So here we have this polynomial. So since I have a positive x plus a half, I'm going to use a negative a half. Again, we use negative a half because x plus a half can be written as x minus negative a half, and that's going to be your k. But so that you don't have to do this every time, it's really the opposite of what you see here, negative a half. My coefficients are 8, 16, negative 18, and negative 12. First step, bring down the 8. 8 times negative a half is negative 4, plus 16 gives me a 12. Negative a half times 12 is negative 6, plus negative 18 gives me negative 24, times negative a half is positive 12, and then I end up with 0. If you get a remainder of 0, remember that that's going to be a very good thing. So it makes us happy. Okay, so our quotient is 1 less power. So if we had x cubed, now we're going to have x squared plus 12x minus 24. So my answer is 8x squared plus 12x minus 24 plus the remainder of 0 divided by x plus a half. Since we got remainder of 0, then that helps us to find our zeros. So what I can do here is I can write my factor. So recall from the first example, if you get remainder of 0, that means that your divisor, x plus a half, is a 0. So to find the 0, we set it equal to 0 and solve for x. And then we can also use our quotient to find the other zeros. Okay. So once you have 1 0, remember we should have 3. Then we can use our quotient to find the remainder of the zeros. Our quotient is 8x squared plus 12x minus 24. You can try to factor. If it doesn't factor, then we can use the quadratic formula, which would be negative 12 plus or minus the square root of 12 squared minus 4 times a times c divided by 2 times 8. So at the end, well, let's just simplify negative 12 plus or minus 12 squared minus 4 times 8 times negative 12 gives us 144 plus 768 divided by 16. Negative 12 plus or minus 912 divided by 16. And so that's going to give us two answers. X equals negative 12 plus square root of 912 divided by 16. And x equals negative 12 minus the square root of 912 divided by 16. If we put these in our calculator, then we get two answers. X is 1.137 and x is 2.637. So these are our other zeros. So the main point of this is that if you use synthetic division, you get a 0. That tells you that this number here is going to be a 0. To find the other zeros, we use the quotient. Since the quotient is quadratic, you can try to factor or you can use a quadratic formula to find the other two zeros. Okay, the remainder theorem, if a polynomial f of x is divided by x minus k, then the remainder is r equals f of x. Okay, so for example, what this means is whatever value of x I have in here, if I plug it into the x's, our answer is going to be the remainder. So here I would plug in -3 for the x, so I'm going to have 4 times -3 cubed plus 10 times -3 squared minus 3 times -3 minus 8. So we get -108 plus 90 plus 9 minus 8. So that comes out to -17. So f of -3 is equal to -17. And so this is our remainder. Okay, you can practice with this one. If you have any questions, let me know. So basically you want to know what the remainder is. So we plug a half into the x's. Number 7, use the remainder theorem to find the remainder of the polynomial when divided by x minus 2. So since you're trying to find the remainder, there's two ways to do it. Number 1, you can use synthetic division. So I'm going to use 2. The opposite of minus 2 is positive 2. And then I have a 6, -1, -15, 2, and -7. So I bring down the 6. 6 times 2 is 12, plus -1 is 11, times 2 is 22, plus -15 is 7. 7 times 2 is 14, plus 2. 16 times 2 is 32, minus 7 is 25. And so my remainder is 25. So that's one way to find the remainder. The other way is to go ahead and do the following. So for the minus 2, that's going to be our k. So we're going to plug it in for all the x's. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 6 is going to give us 96, minus 8. 2 times 2 is 4, times 15 is 60, plus 4 minus 7. So we end up with 25, which is our remainder. So again, you still end up with the same remainder. A polynomial f of x has a factor, x minus k, if and only if the remainder is equal to 0. Show that x plus 3 is a factor, then find the remaining factors. Okay, so here they want us to show that this is a factor, and so we can use synthetic division for that. So since I have a plus 3, I'm going to use a -3 here. My coefficients are 1. I don't have an x squared, so I'm going to use a 0. And then I have -19 and -30. Bring down the 1. -3 times 1 is -3, plus 0 is -3, times -3 is 9, plus -19 is -10, times -3 is +30. And so we get a 0. As I mentioned before, having 0 here is a very good thing. So I can get my quotient. Remember, it's 1 less power, so if you started with x cubed, then we're going to start with x squared minus 3x minus 10. Since we got remainder of 0, then I know that x plus 3 is going to be a factor. And basically, -3 is a 0. So x plus 3 is equal to 0. If you solve for that, you get your -3. But we need to find the other zeros. So to find the other zeros, we solve for x from the quotient. So we set that equal to 0. And then you can either factor or you can use the quadratic formula. So I'm going to check if this factors. We have x times x. 5 times 2 is 10. So I need a negative and a positive. Set my factors equal to 0. So x is 5 and x is negative 2. So my factor here is x minus 5 and x plus 2. And so those are our zeros, which we are also call solutions. Okay, so the idea is we use synthetic division. Once we have a 0 as a remainder, that tells me that this is a 0. Then I use the quotient and solve for x. If it's quadratic, then you can either factor or use a quadratic formula. Let's go to the next page. Show that x plus 2, x minus 4 are factors, then find the remaining factors. Okay, so I'm going to work with x plus 2 first. I'm going to use negative 2. It's the opposite of plus 2. And then my polynomial here is 8x to the 4th, so I'm going to use 8, negative 14, negative 71, negative 10, and 24. So this is to the 4th power. With synthetic division, we're going to break it down until we have a quadratic remaining. So we're going to bring down the 8. 8 times negative 2 is negative 16, plus negative 14 is negative 30, times negative 2 is positive 60, giving me a negative 11 once I add to negative 71. Negative 2 times negative 11 is 22, plus negative 20, or negative 10. So we get 12, times negative 2 is negative 24, and we get 0. So that's great. So after we do the synthetic division, we want to know what the quotient is. So remember, it's 1 less power, so this was x to the 4th. So now we started with 8x cubed minus 30x squared minus 11x plus 12. So now we use this quotient and we look at the second 0 they give us. It says minus 4, so I'm going to use a positive 4. And I'm going to use these coefficients. So 8, negative 30, negative 11, and 12. You could have used the 4 with the original, but since we're trying to break it down, that's why we're doing 2 synthetic divisions. So we bring down the 8. 8 times 4 is 32. 4 times 2 is 8. Plus negative 11 is negative 3. Negative 12 gives me 0. So that makes me happy there. And so the new quotient now, with 1 less power, so if we started with 3, 1 less power would be 8x squared plus 2x minus 3. So notice now that this is quadratic, and so you have 2 options. Number 1, you can try to factor, or number 2, you can use the quadratic formula. Okay, so I'm going to use the quadratic formula because by looking at these numbers, it's not going to factor. So I'm going to write it up here. So x is equal to negative b, which is going to be 2. And negative b, or b squared, is 2 squared minus 4 times a times c divided by 2 times a. So we recall the quadratic formula is negative b plus or minus b squared minus 4ac divided by 2a. So that's what I use in here. Simplify. We get negative 2 plus or minus 2 squared is 4. Negative 4 times 8 is negative 32. Times negative 3 is positive 96 divided by 16. 4 plus 96 is 100 divided by 16. So here we can simplify the 100. The square root of 100 is 10 divided by 16. And so I get two answers. One answer is negative 2 plus 10 divided by 16, and the other is negative 2 minus 10 divided by 16. Negative 2 plus 10 is 8 over 16, which comes out to 1/2. And over here we get x is equal to negative 12 over 16, which comes out to negative 3/4. So we have this answer and this answer. So far, so my zeros so far are x is equal to 1/2, which we got here, and x is equal to negative 3/4, which is this one. And then the other two zeros come from the synthetic division. So since I got 0 here, that makes this a 0. And since I got 0 here, that makes this one a 0. Okay. So the factors are basically, we take this number to the left side, so we get x minus 4, and bring the negative 2 to this side, x plus 2, and x minus 1/2, and x plus 3/4. And I'm writing the factors because later we're going to use these as well. Okay, let's look at example 10. Solve the equation given that x plus 2 is a factor, so determine all the zeros. Since they tell you this is a factor, we use synthetic division. So we have 1 minus 6 minus 130. Since they tell you it's a factor, your remainder should be 0. So negative 1 times 2 is negative 2, plus negative 6 is negative 8, times negative 2 is positive 16, plus negative 1 is 15, times negative 2 is negative 30. So we end up with 0. If you don't get a 0, then you know you did something wrong in here because they tell you that it is a 0. We use a synthetic division so that we can break this down to something that's quadratic. So my quotient will be 1 less power. So if we had a power of 3, now I'm going to have x squared minus 8x plus 15. Our next step is to use a quotient and solve for x. So at this point, you can try to factor or you can use the quadratic formula. So I have x times x, 5 times 3 would give me 15. Since it's positive 15, I need both of them to be negative. Negative 5, negative 3 is negative 8. So I can set each factor equal to 0. So x is 3 and x is 5. So my answer is the zeros. So here I have x is equal to negative 2 is a 0, x equals 5 is a 0, and x equals 3 is a 0. My factors are x plus 2. I bring the 2 over here, bring the 5 to the left side by subtracting, and bring the 3 to the left side by subtracting. Okay. Number 11, solve the equation given that 1/3 is a 0. So 1/3 is a 0. So here I don't use the opposite sign because it's not written as x plus a number. So here when it has x plus a number, I use the opposite. Here they just tell me that 1/3 is a 0. So I would have to write 1/3. And actually there is a mistake here. This should say negative 1/3. So let me go ahead and change it to 1/3. So again, this should be negative 1/3. If you do it with a positive 1/3, then it's not going to be a 0. So there's a mistake there. So I'm just correcting that. Originally, I should have said negative 1/3. So my coefficients is 3, 7, negative 22, and negative 8. Bring down the 3 times negative 1/3 is negative 1. 7 plus negative 1 is 6 times negative 1/3 is negative 2. Plus negative 22 is negative 24 times 1/3 is going to be positive 8, giving me a 0. Okay, my quotient. So 1 less power is 2. So we're going to have 3x squared plus 6x minus 24. And we want to set that equal to 0. I'm going to divide by 3 for each term. So I get x squared plus 2x minus 8 is equal to 0. So let's see if this factors. So I'm going to write it up here. So I get x times x. 8 is 4 and 2, positive and negative. So x plus 4 equals 0. X minus 2 is equal to 0 for x. Okay. So what I did here is to make it easier, I can divide by 3 since it's a factor of everything. And then it's easier to factor. Or you can use the quadratic formula. So my zeros were x equals negative 4, x equals 2, and x equals negative a third. Okay, so that was the end of section 2.3. Finding the zeros given that something is a zero or something is a factor. In section 2.5, we'll be able to find zeros when they don't give you this information.